So far we have discussed about the different fusion welding processes, and we have tried to get some idea what is the basic mechanism in fusion welding process and how it can be characterized, but in other way that how the brazing and soldering is also one kind of the joining process like fusion welding, but how brazing and soldering can be differentiated from the welding processes. So, basic difference between brazing and welding process is that in welding process metallic components are basically necessary to melt and then they fuse together after the solidification, but here also in brazing or soldering, here also we generally apply the heat and melt the filler material, but not necessary to melt the base material. So, in that sense it is different from the welding process. Also apart from the fusion welding process, there is some solid state welding process. In solid state welding process, the valences of the atoms generally happen in this case through the recrystallization of the base metal, and of course, in this case the applied heat is also necessary, but at the same time or maybe in certain case the pressure application of the pressure are also necessary or application of both pressure as well as the heat. That actually the general physical mechanism of the welding process. Now, in brazing and soldering, of course, it is also one kind of joining processes, but how we can differentiate between the brazing and soldering process. So, soldering, that is a typical joining process, basically where the metals are bonded together using a typically non-ferrous filler material, and we can differentiate between brazing and soldering in terms of the maximum amount of the temperature here. So, in this case the soldering is the temperature should be below than 450 degree centigrade, but at the same time the mechanism also brazing are the same, maybe the filler material are different since it can be operated above the 450 degree centigrade. So, in sense that in soldering and brazing we use the filler material having the different melting point temperature. In one case it is below 450 degree centigrade, in other case the above 450 degree centigrade. So, that is the boundary in terms of the temperature that differentiate between the soldering brazing. Of course, when the temperature differentiate between the soldering brazing, in the sense the applied filler material should be the different in these cases. Now, we will try to get some basic idea about the soldering and brazing process. We can start with the first brazing process. So, what is the brazing process? Brazing is production and cost effective process, and in this case, because in this case the two dissimilar or similar kind of materials can be joined without much affected by heat to the base material. So, in that sense, with respect to the fusion welding process, the brazing process is more cost effective. There may not be any component distortion, or component distortion is minimized or can be eliminated, because the filler material is only melted and after they solidify subsequently, but it does not melt the base material. So, because of that the distortion level in this process is relatively less as compared to the fusion welding process. So, other significant points of the brazing as the base metal dilution is low, because base metal is basically affected by the heat, but there is no change of the phase from liquid to solid. So, that is why the dilution level is low in this process, and definitely several dissimilar combination of materials can be achieved using the brazing process. That is the one typical advantages of this process. Of course, in these cases the joint strength may not be as efficient as fusion welding process, where two dissimilar materials can be joined by using any other fusion welding processes. Different geometric sizes can be joined, so that join simply using the gap between the materials using the filler material, or that is the we can say that brazed metals, brazed filler metals is basically required to fill that gap between the two materials, and then after filling the with the liquid metal, the two solid metals can be joined. That is the basic principle of the brazing process. So, small and wide gap sizes can be filled. So, in some certain cases the gaps varies from very small to the very high gap between the two workpiece materials, that can be filled by the brazing processes, that means using some filler materials. And of course, in this case there is no requirement of the any specialized labor until because the brazing process can be done or can be converted to some kind of automated process. So, with this typical advantage of the brazing process, we can look into the further of the brazing process. First, we will try to discuss the what are the principle of the brazing process. So, we already know that brazing is the process when a filler material or alloy is heated to its melting point temperature, and that temperature level should be above the 450 degree centigrade. Then what happens? Then the liquid metal distributed between the two or more close fitting, or if there is any gap or there is a variable gap between these two materials, but actually between the two close fitting materials, the liquid metal actually stick with the solid metals by simply capillary action or filling by the capillary action. So, this filler material is brought not too much of too much of superheated temperature of this material, rather very low degree of temperature increment with respect to the melting point of this filler material. So, it then interacts with the thin layer of the base metal. So, basically that total heat content of the liquid brazed metal, when we try to interact with the solid metal, it affects up to the very small thickness of the material, and because the difference of the melting point, the base and the brazed metal are huge. So, in that sense it is only effective on the very thin layer of the metal, and that feel or acting between the base metal, or it simply the principle of the weighting of the solid material at certain temperature. So, then after that when it is just exactly fill the gap between the two solid metals, and after sometimes it becomes solidify or cool down to the ambient temperature, and that finally creates the joint between the two base metals. Of course, it is the intuition is that in this case specifically the liquid metal simply weighting the solid metal. So, we cannot expect the very high strength of this weld joint like any other fusion welding processes or any other solid state welding processes. So, definitely the main principle is that capillary action of the liquid metal liquid metal means basically that is a brazed alloy that actually fill into the gap between the parts to be joined. So, in that principle the brazing process actually works. So, sometimes, but in this case to melt the brazed alloy or filler material, it is necessary to put some there maybe the different kind of source of the heat. Normally brazing we can in general we can use an air or acetylene torch simply by locally heating that alloy, so that the temperature can be reached above 450 degree centigrade. But another significant point is that above 450 degree centigrade, but the maximum temperature may not be the much higher than that of the 460 degree centigrade. So, a little bit higher the melting point temperature that is followed in case of the brazing process. So, because in that actually makes the weighting action between these two base metals at the same time not much affected by the amount of the heat to the base metal. So, to avoid much affected by this amount of the heat to the base material. That is why the melting point that is why the increment of the temperature is just below above the melting point temperature of the brazed alloy. So, in general, if we try to look into the what are the typical advantages and the disadvantages of the brazing process. So, first we look into the what are the advantages of this process. So, first thing is that basically it join the any kind of dissimilar materials or dissimilar metals in that sense. The bond line between these two dissimilar metals is very neat in appearance. That main thing is that the brazing process, in brazing process it does not melt the base metal. So, therefore, it allows to much tighter control over the tolerance limit without the need of the secondary finishing, that is the one advantage. So, in case of brazing process may not be required any secondary finishing operation, and that sometimes is needed in other welding processes. So, of course, there is no distortion or almost no distortion in this process, and in the brazing process is also applicable to join the non-metals also. So, ceramics, for example, ceramics can be easily joined by the brazing process to each other or ceramics can be joined with the other metals simply the brazing process. So, this is the positive side or advantages of the typical advantages of the brazing process. But if you look into that, there are also some limitation of this process. So, definitely the brazed joint cannot be used in a certain temperature environment where it exceeds the melting point of the filler material, then it will lose the strength of the joint. So, that means the limitation of this process is that it should be applicable or the joint can be used below the melting point temperature of the filler material. Of course, the base joint requires a high degree of base metal cleanliness, because if the surface are very clean, then the wetting action will be good. So, in that sense that surface should be very clean to get the successful brazed welded or brazed joint components. Now, sometimes the another disadvantage or typical disadvantage of this process, that aesthetic appearance of the weld joint. Sometimes the joint color is basically different from the base metal, and that brings the some aesthetic disadvantage of this kind of joints. So, apart from that, still brazing is one of the good solution for the joining of the dissimilar materials, and of course, if we try to compromise or if we do not compare the strength of this joint with respect to the fusion welding process.